going to handle today is we're going to divide this presentation into 4 parts. One is, how do we know that it's actually happening? This is to arm you to talk to that cranky uncle at Thanksgiving dinner about how we actually know it really is happening. The second is how significant the consequences are and will be. And the third is how the world is pivoting, how it is transitioning to try to get us to a safer place. And the fourth is some observations on what we believe climate change will mean for your industry and some of the changes that are coming for you. So let's jump into the first part, how we know it's happening. That second part, we went through the structure. So the way we know it's happening is because we understand the basic physics of how greenhouse gases work. First off, does everyone know exactly what climate change is? Yeah? So it's okay, so let's start at square one. I'm sorry, I should have started right there. Climate change is just the changes in our long-term weather patterns. Things like hot and cold, rain and snow, wind currents, and even water currents. And when we talk about them, and how they have changed since the mid-20th century. And the reason that they are changing is because we're changing the composition of our atmosphere. And we're doing that primarily by burning fossil fuels, which put up greenhouse gas emissions, and also secondarily through our land use practices. And that has ramifications that kind of cascade through our natural systems. So we know what's happening because we understand how greenhouse gases work. It has been well understood for over 150 years, and it is not controversial. But I want to kind of bring us back to 6th grade science class to remind us all how they do work. So when solar radiance comes down, it passes through the atmosphere and strikes the Earth's surface. Much of that energy is absorbed. Quite a lot of it is reflected back out towards space. And when it is reflected back at a different wavelength. And this new wavelength is partially captured by a tiny portion of our atmosphere that is comprised of greenhouse gases, less than 1%. And these greenhouse gases are primarily carbon dioxide, methane, nitrous oxide, and even water vapor. Without this tiny portion of our atmosphere being comprised of greenhouse gases, we would have a frozen planet. We wouldn't be here. So they play an outsized role in controlling our climate. But when we add to them through burning fossil fuels in our land use practices, it simply means they do a better job. They capture more of that reflecting energy and irradiate it back down to the Earth's surface, warming us up further and adding energy into our climate systems. Another way to think about this problem is the balance of carbon dioxide. I think we all know there's a balance between plants and animals, but we may not know there's also a balance in where nature stores carbon dioxide, in the earth, in the oceans, up in the atmosphere. And I think if we consider these two words at the bottom, fossil fuels, and what they are, it will help us understand what's going on. So fossil fuels are little bits of plant and animal matter that fell to the earth millions of years ago and got silted over. And with time, heat, and pressure, that turned back into pools of elemental carbon. What we call today oil, gas, and coal. And humans came along and said, wow, really rich in energy, really portable, really storable. I'm going to use it. I'm going to use it to heat my homes, to power my transportation, to run my factories, and to create the vibrant economy that all of us in this room have benefited from. But in doing so, humans were unwittingly taking carbon dioxide that nature had sequestered deep underground over millions of years. And humans started pumping it up into the atmosphere at the alarmingly fast rate of 40 billion tons of carbon every single year, much faster than it normally happens in nature, upsetting the balance that has existed really since human civilization has existed. And we're putting up a boatload of carbon dioxide. This graphic shows that all the way back 800,000 years, carbon dioxide naturally stay between 150 and 300 parts per million. Now these were through the natural cycles the Earth has always gone through ice age and thaw, and ice age and thaw. And then you can see in 1910 we broke out of the natural cycles, crossing over 300 parts per million. Today we are in the 400s. And scientists say if we were to continue to emit at our current levels, we would hit close to 1,000 parts per million by the end of this century. And we also know it's happening because new technology enables us to measure. There are satellites up in the air today that can literally measure the emissions and where they are coming from, so we can identify the source. And we also have the ability to identify the atoms in the air that come from burning fossil fuels. And that's because it has a different atomic thumbprint, if you will, a different isotope. So we know that we are the ones that are causing this change. And science has evolved enough that we not only know it's happening, we also can begin to put the dots together on how much it's contributing to the pain and cost of what's happening around us. So through the new sciences of attribution, we now can look at a major event and say, wow, climate change was involved or wasn't, and it was more likely because of climate change or now more extensive because of climate change. This is a great example. This is the world last summer. I think we all remember how hot it was in our own Southwest when Phoenix was cooking for so long. But Phoenix wasn't the only place cooking. There were many parts of the world that were extremely hot. In fact, 4 billion, half of the world's population, were in areas that were extremely hot that had been made 3 times more likely to be that hot due to climate change. And, intriguingly, we are now getting the ability to better predict what's coming. And that means that down to a granular level, to an individual address, we have a better sense of what risks that property will be exposed to in the future. So hopefully you're with me that climate change is indeed happening. Let's move to the second part about just how significant those consequences of climate are and will be. Because quite honestly, I think most Americans, 72%, get that climate change is happening. What I don't think Americans really have done is internalize what it means and just how significant the changes are that we have baked in. So I'm going to spend a minute on the slide because it's, to me, the big picture slide, so bear with me for a second. On the bottom, we have time going back 20,000 years. On this axis, we have temperature from about 9 degrees colder to about 11 degrees hotter. The yellow is average global temperature, and the white are milestones for reference points. 20,000 years ago, we were in a glacial period of an ice age. There was a mile of ice over Manhattan, and much of the world was uninhabitable. And then over about 8,000 years, nature moderated, coming up to what more or less than the average global temperature for the last 10,000 years, which is right around 60 degrees Fahrenheit. Now 60 degrees Fahrenheit is a really good temperature for our species and for human productivity, but it isn't a temperature that the Earth has been at very often in its long history. It is not the default choice that if we knock it off, it wants to return back there. And when we hit that 60 degrees, guess what? We have to settle down. We were no longer nomads. We could build agricultural systems and also build civilization and cities. This little hill was the medieval warming period when the Vikings were able to grow vegetables in Greenland. The little divot over here, the Ice Age, is when the glaciers came down. It was about 1.5 degrees colder. And that caused all sorts of food deprivation, leading to upheaval and even war. Again, showing that a small temperature change on the Earth's surface can make for big changes on how we experience life on the planet. And then you can see the temperature going up and away, landing somewhere between 3.6 and 10.8 degrees Fahrenheit hotter by the end of this century, depending on what we choose to do. So let's think about that. nature had 8,000 years to literally march trees from Mexico to Montana to create the ecosystems and the biodiversity that has supported us for 10,000 years. And now, through our activities, we are potentially triggering a similar delta in the next 100 years. And that's scary, right? And that is what brought all of the nations of the world together to say, hey, we can't go there. We can't go to those high numbers because at those levels, we aren't sure we'll be able to handle what nature will throw at us. Instead, we need to keep at the 1.5 degrees Celsius increase or a 2 degrees Celsius, which correlates to a 3.4 degrees Fahrenheit. Because at those levels, we think we can adapt and we can mitigate and be safe. So let's take a quick drill down on what is changing. And this is a graphic from NASA. That shows how average global temperature has changed from pre-industrial times to today. When it is blue, it is colder than average, white average, yellow warmer, and red hotter. So at the, come back to that in a second. So as you can see at the end, the red really comes crescendoing. So the Earth is influenced by other things besides just carbon dioxide. The Earth's orbit, its wobble, and its tilt. So that is on a secular basis. It's on like 22,000 years, 44,000 years, and I'm making this up, 8 or 11. You know, so it's on a cyclical period. In addition, there are natural causes, and what we found during that period of 8,000 is the Southern Ocean started to exude carbon dioxide into the air. And they're still figuring out why, but it was through natural causes, and it took 8,000 years to bring that temperature up. It's not even so much that the temperature is going so high, it's the rate of change doesn't allow civilization and also other species to evolve to handle the new normal. So as you saw at the end, the red really comes crescendoing in, and that's because we aren't just breaking records, we're really shattering them. As you can see from this graphic, 2023 was the hottest year ever recorded. It was about 1.4 degrees hotter than the pre-industrial times, flirting with that level that we really want to stay underneath, that 1.5. And actually, the 10 last months have all been the hottest of those months recorded. So in other words, each of the last 10 months have been the hottest recorded. And that means we're experiencing more hot days right here in New Jersey. Newark experienced 13 more of those super hot, risky heat days during the summer versus 1970. And that's all predicated on emissions that have been put up in the past. What we are experiencing are from historical emissions. So what will happen with the emissions we're putting up today? Well, they are going to impact our kids and our grandkids. So taking a look ahead, and this is an average of 26 different climate models, you can see that it is projected that if we continue on the current emissions path, we would have temperatures for our grandkids close to those experienced in Augusta, Georgia, by the end of the century, about 8 degrees hotter. And for those super hot Phoenix that we spoke about earlier in the presentation, it's expected to feel like cities currently in Saudi Arabia. So as I mentioned, when things get hotter, that influences other natural systems as well. It cascades kind of through the natural world. And one of the areas that it really impacts that we're seeing everywhere, heavy rainstorms. And it's just physics, because warmer oceans evaporate more water, warmer air can hold more water vapor. So when conditions are right, it's more likely that we'll have this kind of cataclysmic rain instead of a restorative shower. And you can see from this graphic, it is indeed happening everywhere across our nation more, even in places in drought. And of course, we've experienced it right here in Princeton and right here in our state of New Jersey. I think many of us remember last September when New York was deluged, and so many of our cities right here in New Jersey had extreme rainfall in very short periods. And this problem is exacerbated because New Jersey is getting built out. We've developed it. So you can see from 1972 to today, we have many more impervious surfaces. So there's less area for the water to get absorbed naturally. And of course, that also is right here in Princeton. You can see the red is our developed area. And what it means is that storms are more powerful, and even places that have been here for 100 years, like this house in Lambertville, are now being washed away. And again, guys, it's only going to get worse as we get hotter because more water will be in the atmosphere. Now, the reverse is also true. While we may be getting wetter, we're also getting drier. And that's because these hotter temperatures dry out our soils and our plants. And that means less water gets down to our aquifers and clearly plays havoc with our ability to grow food. And also, while this isn't really a New Jersey issue, I threw it in because we're hearing so much about it. Climate change is playing havoc with our surface water, especially out west. And that's because it is changing our snowpack. So if it is warmer, it means that precipitation falls later in the year as snow. And if it is warmer, it means that the snow melts earlier in the spring. And that means there's less of that snowpack water downstream when we need it in the summer for cities, for farming, for hydropower, for fossil fuel power, even for wildlife. And we're seeing this out west, as we know, in spades, and again, that is anticipated to get worse as we go further into the century. So climate change is both giving us too little water, or often giving us too much water, and in both cases, it's often too dirty. Too dirty because our aquifers get too concentrated, and too dirty because our systems aren't set for these huge rains, and so overflows happen of both chemicals and just regular wastewater treatment plants. Another thing that's happening that is directly tied to climate change is an increase in natural disasters. It's not your imagination. They're happening more. And again, part of it is the fact that we are adding more energy into our climate system, as we talked about with that re-radiating at the beginning slides. You can see from this graphic from the National Weather Agency, NOAA, that in 2023, we had a banner crop. We had 28 $1 billion natural disasters in this country. And intriguingly, when we talked to insurance professionals, and we actually hosted an event simply to talk about climate change and insurance with Chubb Insurance and CBIZ, what they told us is that that chart doesn't even reflect what they're being hit with. In fact, they are paying out more for the more frequent, smaller events. The smaller things like windstorms and hailstones and floods and things that don't even necessarily make the $1 billion mark. And so the actual destruction coming from this changing climate is even bigger than what we see on that initial graph. We are a coastal state, so let's talk about sea level rise. We kind of lost the lottery on this one, guys, because New Jersey sea level rise is faster and higher than the global average. The global average is about 9 inches since 1900. We've had 1.14 inches already, and it is projected if we were to continue on our current path, we could have anywhere from the best case scenario 3 to 5, the worst case scenario 6 to 8 by the end of the century. And a lot of that is tied to what happens to the ice shelves in Greenland and in Antarctica. The reason that we lost the lottery, though, is really interesting. It's the fact that the glaciers ended just at New Brunswick on exit 9 of the turnpike. That was the southernmost part of the glacier in the glacial period. And the pressure of that ice actually pushed the landmass south of that up. When that ice melts, it means now our part of New Jersey is beginning to go down, to subside. So we're going down as the ocean's coming up, and we're also using our water very quickly, which is compacting our soils and causing us to subside more. So we are really vulnerable to climate change effect of sea level rise. And we're seeing it. We're seeing it in Bayhead, but we're seeing it all around the country where just on a sunny day, not even a storm, floods are messing up school buses' ability to pick up kids and impacting businesses and commerce. And we are indeed seeing a lot more sunny day flooding. This gives you a sense of just how much flooding is coming on high days, again, not tied to storms. And we are the third most vulnerable state as far as real estate to sea level rise, after Florida and New York. It is projected by a group called, from First Street, called Risk Factor, that 385,000 properties are in New Jersey face substantial flood risk, and that also includes riverine risk, so it's not all just at the shore. And that's projected to increase by 19% by 2050. It's also degrading our land. It's causing these ghost forests because the salt water is intruding into the natural systems. So we're seeing woodlands and farmlands kind of being turned into salt. And something that I don't think we think of much here is that it's projected that as New Jersey gets wetter in the spring and drier in the summer, that we'll have more forest fires. And also, what I didn't know until I started delving into this is that the East Coast is actually more vulnerable than the West, in part because so many of us we're so heavily populated that so many of us live near the wilderness interface. So we're living close to woodlands, and we don't think about it now. But as things get drier, it is anticipated that as much as 48% of households in New Jersey will be at greater risk to wildfire. Let's take a look at the fact that the oceans are heating up. Now, why would we care about that in New Jersey? Why would we care about oceans getting hotter? Anybody? Okay, I'm not hearing it. Well, a couple of things, actually. The water gets hotter water expands. That's part of what's driving sea level rise. Hotter water impacts our sea life, right? So it's impacting our ability to have the fish we know and for the fish to stay safe. It also is the power source for hurricanes. And while we don't get them, then when we get them, we can get them pretty badly. We don't get them as often as our friends down south. Because the waters are so hot, it means that these storms are forming further away from the equator and staying stronger further away from the equator because the sea level rise are coming in on a much higher sea surge, causing more flooding. And because of what we talked about, the atmosphere holding the water vapor, they're dropping more rain. And again, as we get later in the century, that means that we will be more vulnerable to more powerful hurricanes right here in New Jersey. And we can see the patterns are just changing. They're intensifying more quickly, and there's even discussion amongst the scientific community of creating a category 6 because their wind speeds are getting so strong. And we know that it's not just a storm. When one of these natural disasters hits a community, it has long-lasting impact. It can take over 10 years for a community to recover, and sometimes even longer. And I don't need to go through the slide, but I think we can kind of think through the ramifications. If it's extremely hot, it impacts our health, it decreases human productivity, it causes all sorts of havoc with our farming and with our water systems, and in many places it can disrupt transportation. Roads literally melt, railroads buckle, airlines can't take off if it's super hot, rivers get too low to bring cargo up and down. So really translates across the economy. And the same thing with our severe storms and wildfires. It threatens not just our people and our communities, but also our infrastructure, our hospitals, our police stations, our airports, and all the way down. So I think when people think of climate change, they think, oh, it's a little hotter. Not such a bad idea on a winter's day. But in fact, Institute taking a look at where they expect to see local GDP impacted. You can see much of the Midwest and the South has decreased local GDP. We're kind of neutral. And it's really the very, very top, the northern parts that are expected to grow later in the century. And it's not just BlackRock that says so. This is from the largest insurance company in the world, Swiss Re. And they project as we hit a 3.2-degree increase, which is kind of the path we're on right now, we would lose about 10% of our GDP, and that the world in total would lose as much as 18% of GDP. And that has real ramifications for our investments, because our investments are tied to the economy. And I put this in because I know buying a house is sometimes based on your assets. And obviously a lot of people use the stock market as a way to grow their wealth. It is projected by Moody's that these sectors will be significantly impacted by climate change. And Moody's has warned that as much as 10% of the top countries in the world will be downgraded this next decade because of climate change pressures. So havoc coming there as well. And this one, again, is a little counterintuitive. We all hear about migration. We hear about how difficult this problem is and how we are feeling the pressures that we've never felt before. Climate change is exacerbating that, because as some of these areas in Central America and South America and Africa and other areas are getting much less habitable, much more difficult for people to raise their families here, and they are moving. But intriguingly, and perhaps importantly for New Jersey, scientists predict that as things get hotter in our own country down south and in the Midwest, that many people will begin to migrate from there further north. So especially around the Great Lakes, which has such a great freshwater resource, those states have been labeled the climate refugee states, where they expect many Americans to move to as we get to the second part of the century. Okay, so that was pretty dire, right? That makes you pretty depressed. But the good news is the world has got the memo. The world is pivoting. We've heard what Electrolux is doing. They're leading the way. Other companies are also stepping forward and saying, we can't go there. It's not good for our bottom line, and it's not good for our customers, and it's not good for our earth. So what is happening? The economic equation around this issue really has been turned on its head. We now understand the cost of continuing on our current path, and we now have new ways, due to human ingenuity and entrepreneurship, to power our economies and create a vibrant quality of life without continuing to put up carbon dioxide emissions at the same level. We can wean ourselves away without destroying our world, which is really an important innovation. So what you can see here in this graph is from Bloomberg, and it shows how renewable energy, wind and solar, have dropped so precipitously. Wind has dropped 70% in the last decade, solar 90% in the last decade. So that on a global basis, apples to apples, no subsidies, solar and wind are as much as 40% cheaper than fossil fuel sources. And think about this, guys. Fossil fuel sources are extracted. They're things that we get from underneath the earth. Wind and solar are technologies. They're things that as we build more of, we learn how to do better, and as we build economies of scale, they go down in cost. So this is predicted to go down significantly by the end of this century. So it's not even a fair fight now. It's going to be less of a fair fight as we get in the next 2 or 3 years. And what that means is that in all of the major emitters of the world, China, which is number 1, the US, which is number 2, and India, which is number 3, renewable energy is the cheapest new form of energy output. And that's translating into the marketplace. In 2023, 86% of all new power generation that came online in the United States was fossil-free. It's expected to be around 95% this year. And investment is shifting. You can see that last year, globally, we had $1.8 trillion put into clean energy versus $1 trillion into fossil fuels. And other countries are integrating much higher levels of wind and solar quite successfully while growing their economy. We are a bit of a laggard at this point, even though we're coming on strong. And I should also say that even within our own country, many states are leading the way. I really drive this new technology forward. And in addition, there are a lot of new innovative technologies that are coming that would enable us to have clean, firm power. Firm meaning when you want it, you don't have to depend on the blowing wind or the shining sun to act as a backbone to support a power system that included a lot more renewables. And some of the ones that people are super excited about are fusion. This is something that's always been out of reach, but is now coming within reach. Our own Department of Energy has suggested we should build a pilot plant by 2040. There are 9 private companies that have promised to have fusion on the grid at the end of the 2030s. Microsoft has bought a power purchase agreement. We will see. If we want it, it will come. And this is the power of the sun. It's clean and can be used for so many applications, kind of the holy grail. They say if we invest on it, it can be a reality, but it is expensive. Green hydrogen. Have you guys heard about that? No? Yes? Okay. It's kind of the new darling of the energy world. So you can take all that excess solar and wind, because sometimes we throw it away. We have so much of it, we can't use it, we just throw it away. So instead of throwing it away, what if we used it to break up water atoms into hydrogen and oxygen? And then what if we took that hydrogen gas and stored it for weeks, months, or turned it into ammonia and used it for fertilizer, fuel? We could store that as well. What does that let us do? That lets us take wind and sun and store it, right? And it can be burned a lot like natural gas, so it can be used in long-term shipping and air travel and things like that. And so there is a race worldwide to be the leader in clean, green hydrogen. Geothermal. It's not your grandmother's geothermal anymore. It is, new technologies are enabling it to play a much bigger role. In part because of fracking. Some of the technology that we learned from fracking is very applicable over here. We're also finding that old abandoned oil wells and gas wells can be used for geothermal. And so this is expected to move into Texas and Louisiana and other areas where we never thought geothermal could play that role. Again, clean and firm. And then new nuclear, this is at one of the small little nuclear plants that are being talked about, they're SMRs, and other countries are moving with them more quickly than we are, but we are trying. Our last nuclear plant that came online down in Georgia took 14 years and it was $14 billion over budget. China is building them in 5 years. And I don't know if they're over budget or not, but I doubt it. So other countries, especially China, especially India, 2 of the bigger emitters that we really want to move to clean energy, are embracing this nuclear quite robustly. And then carbon capture. There's a lot of new technology coming in that enables us to capture it from the air, from the water, but also at source points. This is the first net zero natural gas plant that's coming online in Texas. Fossil fuels still make up 80% of our energy usage. So as we transition off, it has to be slow enough that we don't disrupt our economy, but fast enough that we get safer. But carbon capture could play an important role in enabling us to do that. We also have the ability now to make a different type of power system, and it is emerging already. We have new technology that enables us to use the current grid better, and I don't think we've heard a whole lot about this, but literally, the wires currently are wrapped in like steel. We could wrap them in carbon fiber, and that makes them lighter, which means you don't need as many of the structures, so it makes it cheaper, and it allows the inner core to be much bigger, which allows it to transmit much more energy. It seems like such a simple fix. We also have sensors that enable us to more safely send more energy over our wires, because we've been precluded from doing that. We can't use them fully because of the risk of fires and things, but we have sensors that enable us now to know when something's arrived fast enough that we could send more energy. So those are easy things that we could do. And then also, these are thermal batteries, and this is the most exciting thing since sliced bread. Remember I talked about having the renewable energy that we throw away? What if, instead of throwing it away, we ran it over a really well-insulated box full of bricks, or full of sand, or full of graphite, and got it really hot, like over 1,000 degrees. What could we use it for? Well, we can use it for manufacturing. We can use it in a lot of applications, and we can use it for energy. Again, a really simple way of storing heat and energy that is being rolled out now in our country. So these simple innovations have major ramifications on our being able to meet this challenge. Our innovation is coming across sectors in our food systems and in our built environment. And our built environment, depending on who you talk to, makes up about 11% of all emissions. And then if you add in all the manufacturing of the steel and the drywall and stuff, it gets higher. That means that buildings are a critical place to start in decarbonization, including our appliances, including what we put inside of them, but also that they are vulnerable to this risk of climate change. And so some of the new ways that they're talking about building are carbon-absorbing concrete, fire-safer houses that are built into the ground. These are down in Australia a lot, so the fire goes over instead of through. There's one that is built without a corner so that the wind will go around it in a hurricane-prone area. And this is nano paint, which actually has little nanoparticles that allows the solar radiance to bounce back at a different light wavelength. So it goes past the greenhouse gases more and out into space. Transportation as well is changing from electrical ferries to electrical buses, airplanes, and scooters. And we're also recognizing the power of nature, that nature is valuable because of the services she provides in absorbing carbon and keeping it locked away. So what does this mean for your industry? Well, I'm sure you guys are already thinking about that. Clearly, there are changes coming. The National Association of Realtors put out a quote that said, "One thing is certain in today's climate, from large commercial industries to the small business operator, from multifamily complexes to the individual homeowner, climate risk will be a major consideration. Planning, designing, retrofitting, marketing, buying, selling, investing, and financing of real estate, bringing with it many challenges, but opportunities as well." So what are we seeing? First of all, that this is just beginning to get integrated into your market. Some of the more sophisticated big companies have been looking at it for a while, but it is not yet reflected in the pricing, and it's just beginning to be reflected in insurance and mortgage and financing. These changes are coming because they have to. An insurance company isn't raising price because they're bad guys. It's because they're facing all those pressures that we've talked to, and to keep their business solvent, they're going to have to charge higher rates and be more selective on who they cover. Real estate investment companies are turning to some of these predictive modeling to have a really better understand of how their properties will be impacted and doing due diligence in a different way to include climate change. We also know that changes are coming that are going to force safety measures that will increase the cost of houses, right? If you have to build it up high, if you have to have stronger windows, if you have to have all those things in order to not just get insurance, but also to stay safer in this new world, it will cost more. We also know that there's a real concern that because of the way mortgages are bought and then sold, and so many of them are now sold to Freddie Mae and Freddie Mac, that taxpayers in general have a great exposure to this. And as the repricing happens, it could have real repercussions for the economy at large. And as we heard from Melissa, there are buyers now who are integrating their values into their purchase decisions, and not just on appliances, but on homes in general. And that's especially true with some of the younger buyers. What does that mean? Well, think about it. For cities and states, changes are coming as well. Cities and states often depend on their tax bases to provide a lot of their services. A lot of their tax bases tend to be bigger shoreline properties for commercial and for home. So if all of a sudden you're losing access to those really prime properties, what does that mean for your ability as a city to continue to provide the same amount of services and prepare for more services because of the damages and pressures of climate? They're gonna have to build more infrastructure, they're gonna have to raise roads, they're gonna have to bring in more sand, they're gonna have to build seawalls, they're gonna have to build better drainage, right? They may have to raise their firehouse, they may have to help fix the hospitals. There's a lot of changes we need to do to harden ourselves for the new world we have created. There's also a lot of pressure from the state level saying, we need to be smarter, we need to do more on the municipal level. And New Jersey's kind of at the forefront of that, so you guys have already lived through it, but in many states it's not happening yet. And then there's also just a question of quality of life issues. If your road is being flooded, I don't know, 9 times a year, and if the water is coming up to your front yard 3 times a year, how much do you want to stay in that house? And say you have a huge hurricane and you're built up and you're Fort Knox and you last, but the grocery store didn't and the movie center didn't and maybe the bridge was washed out. How long do you want to stay? So every person will make that choice for themselves, but it's common. And then also, if people abandon their properties and they get underneath the tide line, then cities might have a responsibility of going in, taking out the septics and the other things that would otherwise foul the water. Who's at risk? Home buyers, home builders, landlords, mortgage investors, insurance companies, municipal bonds, and local and state government. Kind of everybody. And what is being done, what we're seeing on a national scale is that banks are taking a look at how, or financial institutions are taking a look at their risk exposure. They're asking for higher down payments. They're looking to sell those mortgages more quickly back to Freddie Mae and Freddie Mac. And there is a push to look at shorter mortgages because these climate risks get worse as we get into the century, get into the next couple of decades. And so there's an anticipation that there'll be shorter mortgages offered in order to protect the financial institution. Regulatory changes that we're seeing, higher density development, restricting development in dangerous places, changing housing zones and building codes, revising land use, using predictive models. Again, I'm going to say this is kind of new, but banks and mortgage companies are using them on a property level to evaluate what they're doing. And importantly, for the very first time in New Jersey, as a leader, we are beginning to look at making the rules based on what we know is coming versus what historically happened. Other states are still basing their flood data on things that happened as far back as 1889. So we don't live in that world anymore. And it might be really nice because it would keep our costs down on the upfront, but it leaves us vulnerable on the other side. And so New Jersey really has been a leader in looking forward and predicting what's coming. And towns are being held accountable for storm water management at a higher level than in the past. Insurance, of course, is also under pressure. We spoke about that in the beginning. This is what Swiss Re, again, the #1 insurance company in the world, has said natural disasters could increase their costs by 60% by 2040, and they expect that premiums will increase by 5.3% per year on a global basis by 2040. In addition, we're seeing that insurers are being much more proactive of mandating mitigation and hardening enhancements in order to get insurance. So even if you can get it, it may cost you something to get there. Okay, again, predictive modeling is happening at the insurance level, the reinsurance level. It is important to know that your insurance pricing is impacted by what is happening around the world because the reinsurance companies are active around the world and they are a big part of the cost to your insurance company. So if it happens in California, if it happens in China, if it happens in Dubai, it could impact your rates right here in New Jersey. And this is really interesting to me, and if we have any lawyers, I'd love to talk to you about it. If we can predict what's coming, is it an act of God? So if we can predict what's coming, what are the legal ramifications of building in that floodplain or building with materials that are too flimsy would like to be a lawyer in the next couple of decades because that is where a lot of the action is going to be. And I believe that. Okay, I talked about the predictive model. This is just one. This is called Risk Factor. It is from First Street. I ran it from my home on Nelson Ridge in Hopewell, New Jersey. And what it shows is that I'm not close to water. I'm going to be fine on flood. Heat, those super hot days that are coming, there are going to be more of them in the future, so I am going to be impacted by heat. I'm going to definitely be impacted by wind. Again, looking at the types of storms we're getting and the types of hurricanes that are predicted. This one knocked my socks off. Before, on wildfire, on Nelson Ridge. It's like, are you kidding me? But then I thought about all the woodlands around me, and I'm like, oh my gosh, I never, ever would have thought of that. But when I get insurance, they work, right? So, and this is available for you guys in your subscription if you want to go deeper. So what does that mean? Well, as I told you, at the Paris Accord, we were on an incredibly dangerous trajectory, a crazy trajectory, which again is why the world came together. We were on this level. Because of the policies that have been enacted since Paris, we have come down to the brown level. And there are promises that get us down kind of closer to the yellow level. We need to be at the green level. We need to put the pedal to the metal. We need to do more. When we hear we're doing too much, no, no, no. We need to embrace the actions that are in place, including the Inflation Reduction benefits. We need to use those. And we need to continue to find ways in our own lives and in our country's discourse of pushing even more action. And if we do, our kids and grandkids will have a very different future. Take a look at this graphic that shows how generations will be impacted, again, by the emissions we're putting up today. Here, Gen Alpha, those who were born after 2013, will, here in the Newark area, feel temperatures that are almost 7 degrees hotter if we stay on our current emissions path. But if we make the cuts, if we use the technologies and we create the policies, they could experience as little as 2 degrees hotter. What a difference. And that is based on what we choose to do. So what we choose matters. Thank you, and I look forward to